Robots didn't start in factories. They started as magic tricks, royal entertainment, and one of the most famous robots in history was actually a lie. But once we gave robots sensors and AI, machines stopped being tools and started becoming teammates. Quick truth, a robot is basically four things: bones, structure, muscles, motors, senses, cameras, touch, radar, and nerves, control software. Now here's the upgrade. AI turns repeat this move into understand, decide, adapt. Long before electricity, humans built robots using gears, water, and clever mechanics, called automata. Some could move like birds, musicians, even writers, powered by cams and hidden mechanisms. In 1770, Wolfgang von Kempelen's Mechanical Turk amazed European audiences by appearing to play chess autonomously. But it was a hoax, controlled by a hidden human operator inside the cabinet. Early robot intelligence hype is centuries old. The word robot became famous with Karel Čapek's play R.U.R., published in 1920, derived from the Czech robota, meaning forced labor. Fittingly, the first industrial robots, like Unimate, were designed to take on dangerous, dull, repetitive jobs in factories. Massive turning point. Unimate, the first industrial robot, installed at a GM plant in New Jersey in 1961. It didn't look cute, it didn't talk, but it did something heroic. It handled hot, risky jobs humans shouldn't. Robotics became real first in places with predictable environments, like factories, because robust real-world perception and planning were still limited. Meet a legend, Shakey. Late 1960s. Shakey could perceive its environment and plan simple actions, like navigating around obstacles and pushing boxes, proving robots need planning and perception, not just motion. Perception plus planning. Early robot intelligence. Robots became far more capable and widespread as sensors and compute got cheaper and more powerful. This era created famous robots that brought robotics to normal people. But here's a rare truth from robotics labs. A toddler can pick up a spoon without thinking. For robots, reliable grasping and everyday movement are still hard. This is Moravec's paradox. Many easy human sensorimotor skills are surprisingly difficult to engineer. What humans find easy, walking, seeing, grasping, is brutally hard for robots. Robots became heroes in places we can't safely go. War zones, disasters, and space. Mars rovers can't be joystick controlled in real time. Signals take too long, so they use autonomy to navigate hazards. Space-forced autonomy. Then came the body breakthrough. Robots stopped moving like stiff mannequins and started moving like athletes. Balance, timing, recovery. This is where control theory and learning collide. Unstructured terrain and clutter introduce uncertainty in sensing and contact forces, making real-world locomotion far harder than lab demos. So dynamic robotics is genuinely impressive. Now, the modern explosion. AI. AI gave robots 5 superpowers. 1. Perception, recognizing objects, people, roads. 2. Mapping and navigation. SLAM, I map while I move. 3. Learning, reinforcement learning, imitation learning. 4. Prediction, anticipating motion and risk. 5. Language, understanding human requests and instructions. Many robots learn in simulation first. It's like giving a robot 1,000,000 lifetimes of practice, without breaking hardware. Robotics, bar action, bar AI, bar decisions under uncertainty. The near-term future is likely less about one do-everything humanoid and more about a growing fleet of specialized robots, warehouse AMRs, hospital transport, disinfection bots, agricultural robots, and inspection robots made more capable by smarter AI. The hardest frontier? General-purpose manipulation, doing hundreds of tasks with one robot body. Robotics gave machines bodies. AI gave them judgment. And when bodies plus judgment meet the real world, history changes. Subscribe. Comment. Team humanoid or team specialized bots?